In this video, we will look at exponential growth and decay. Exponential growth is an increase in value over time. Examples of an exponential growth includes a population growth and a bacteria growth. Exponential decay is exactly the opposite of growth. It's decreasing in value. Examples of those are radioactive substances and items that depreciate in value that are examples of exponential decay. So here is the question, what is a better option? You will discuss the scenarios with your classmates in our discussion board after watching this video. First option is starting with a penny. Miss Lee will double your money for the next 30 days. So on day 1, you'll start with 1 penny. And then on day 2, you have 2 pennies. And then on day 3, you have 4 pennies. So after 30 days, how much money do you have? Second option is that Miss Lee will pay you $1 million right now. So think about it and we will discuss this on our discussion board. An entomologist monitoring a grasshopper plague notices that the area affected by grasshoppers is given by AN is equal to 1,000 times 2 to the 0.2 n hectares, where n is the number of weeks. So those are times after the initial observation. Find the original affected area. When it says original, initially, how many hectares are affected? So that's when time is equal to 0. So we have a to the n is equal to 1,000 times 2 to the 0 power. But we know any number to the 0 power is equal to 1, so the final answer is just 1,000. So we started with 1,000 hectares that are affected by the grasshoppers. B, find the affected area after 5 weeks, 10 weeks, and 12 weeks. So here, when it's equal to 5 weeks, n is equal to 5. All you need to do is just plug in the values. A to the n is equal to 1,000 times 2 to the 0.2 times 5. That's first. So 2,000 hectares. Second one, same idea. When n is equal to 10, a to the n is equal to 1,000 times 2 to the 0.2 times 10, that's 2. So 2 to the 2, that's 4. So 4,000 hectares are affected. 3, after 12 weeks, how many areas are affected? A to the n is equal to 1,000 times 2 to the 0.2 times 12, that's 2.4. So using your calculator, you get an answer about 5,280. Alright, so draw the graph of AN against N. We have on the x-axis N, which is the number of weeks. And then we have the area that's affected by in hectares. So initially it's starting at 1,000. When n is equal to 0, it's 1,000. And then we have when n is equal to 5, it's 2,000. When n is equal to 10, it's 4,000. So we can kind of observe that the value is exponentially increasing. When a diesel electric generator is switched off, the current dies away according to the formula IT is equal to 24 times 0.25 raised to Tms. where t is the time in seconds after the power is cut off. Find IT when t is equal to 0, 1, 2, and 3. So this is a basic algebra question. So when time is equal to 0, I of 0 is equal to 24 times 0.25 raised to the 0 power. A number raised to a 0 power is equal to 1, so that must be 24 m's. When time is equal to 1, that's I of 1, so it's 24 times 0.25 raised to the first power. So it's just 0.25. 0.25 is a quarter, so quarter of 24 is 6. When I is equal to 2, that's 24 times 0.25 raised to the second power. In this case, use your calculator, and it comes out to the value of 1.5 amps. And when I is equal to 3, that's 24 times 0.25 raised to the third power. So the answer is 0.375 amps. So if we look at these values, as time goes by, we clearly notice the value of current is decreasing. In just 3 seconds, it went from 24 to 0.375. So it's an exponential decay. So B says, find the current flow in the generator at the instant when it was switched off. When it was first switched off, the time is equal to 0. So it's asking for initial. What's the initial value that you started with? When time is equal to 0, that's I of 0, which we found already. It's a 24 amps. C. Plot the graph of IT for t greater than 0 using the information above. Alright, so greater than equal to 0. So on the x-axis, we're going to have t in seconds. And then on the y-axis, we're going to have I, which is amps. It first starts off with a 24. And then it decreases the value. At 1, it's going to be about 6, so that quarter of that. So about here. And then at 3, you have even less than that. And then that's 2, so 3, 0 points, so it's really getting closer to the 0, but not quite. Right, so that's when the graph, what the graph is going to look like. Use your graph or technology to find how long it takes for the current to reach 4 amps. So if I were to graph this, I know that general graph of this formula is decreasing, and when it's 4 amps, that must be in between first and second seconds, right? So then how do I find this on a graphing calculator? You want to plot this equation, I of t, on your calculator, and then onto the second equation, you want to plot y2 is equal to 4. So then you're going to get a graph on y1, that formula. y2 is equal to 4. So then when you graph it, you're going to get a graph that looks like this. So in order to find how long it takes, we need to find the value of t. You're going to find this value by using an intersection on your calculator. That's second, calc, and intersect number 5. So second, calc, and intersect.